A gas syringe that does not have any graduations is calibrated using a known mass of propanone, boiling point 56.2. The sealed gas syringe contains 0.146 grams with an MR of 58. So we can work out the moles by doing mass over MR. So we can put that on our calculator, 0.146 over 58. So 2.52 times 10 to the minus 3 moles. The temperature T is 95 degrees C, but we want to convert that to Kelvin. So 368 Kelvin. The pressure is 103 kilopascals. We want to convert that to pascals, so times by 1,000. So then what we want to do is let's calculate the volume in centimetres cubed. Well, if PV equals nRT, then volume is nRT over P. So you want to take your moles that you just worked out, 2.52 times 10 to the minus 3, times by the gas constant, times by your temperature in Kelvin, divide by your pressure in pascals. Put that on your calculator. And you get 7.47 times 10 to the minus 5, but this will be in meters cubed, and it wants the answer in centimetres cubed, and there are 1,000,000 centimetres cubed in a metre cubed, so 74.7 centimetres cubed. The gas syringe is then cooled to 75 degrees C. 75 is 348 Kelvin without changing the pressure. Calculate the decrease in volume. Now this is a ratios question, but just to explain why this ratio works, if the pressure is the same, then the pressure of one of them is equal to the pressure of the other. So let's say that we've got temperature 1 over volume 1 equals the temperature nRT2 over V2. So the two pressures are the same. We can see that N and R are the same in both because it's the same moles of propanone. We've just got a new temperature with a new volume. So we can see it's a ratio question. So our temperature 1 was 368 over our volume 1. And our volume 1 was 74.7 is equal to temperature 2 over volume 2. So we can calculate volume 2 by doing 348 divided by 368. So I'm going to sort of swap these two's position, and then I'm going to times by 74.7 to get 74.7 up to the other side. So 348 divided by 368 times by 74.7. That gives me a new volume of 70.6. And it says what is the decrease in volume. So we went from 74.7 to 70.6. So we went down by 4.1 centimetres cubed. The total uncertainty in using the balance, so the total, so we're not having to double this, to measure the mass of propanone is 0.001. That's the uncertainty. The mass of propanone, if we scroll back, was 0.146 grams. Express that as an uncertainty, as a percentage uncertainty. That is 0.685%. Calculate the uncertainty that this causes in the volume of propanone that we calculated in 7.1. So we go back to 7.1, it was 74.7. So what is 0.685% of 74.7. And that is equal to 0.51 centimetres cubed. So the uncertainty is 0.51. So we're quite certain at 4.7 plus or minus a half a centimetre cubed. A 600 centimetre cubed sample of propanone is mixed with 2,800 centimetres cubed of oxygen in a container. The mixture is ignited. When the reaction is complete, the remaining mixture of gases is cooled to 60 degrees C and 100 kilopascals. So basically the temperatures and the pressures are remaining constant. Calculate the total volume of remaining gas mixture. So I'm just going to rewrite this equation, because if the if the pressure and the temperature are constant, the volume is proportional to the moles, because if PV equals nRT and our pressure and our temperature are constant, then volume is sort of directly proportional to moles. So if I start with 600 centimetres cubed of this, the ratio is 3 to 1. This will all get used up. I had 2,800 centimetres cubed of this. So if this goes down by minus 600, this will go down by 4 lots of minus 600, because the ratio is 1 to 4. So there's 400 centimetres cubed of oxygen left, and this one will go up. So this was a liquid. This is the only other gas, carbon dioxide. This one will go up by 3 lots of 600. So that will go up to 1,800 centimetres cubed. So we need to total the leftover oxygen and the carbon dioxide that we've made, 2,200 centimetres cubed.